Good morning, developers. If you are new to the channel, my name is Rob, and it is CS Thursday, the day that we push our keyboards off to the side and we look at the theory behind our craft. And I have off to the left side here some common compiled languages with Java and C# having question marks next to them. And over here I have some common interpreted languages with those same two. And before we get to the big question of what's better, what are the advantages, etc., we need to make sure we're on the same page about what these mean, because you may be coming with some notion already, or you may have no idea. At the very least, I want to make sure you understand how they work and how I am going to be talking about them in this video. I love using this illustration. Let's say you were to open up an Italian restaurant in Rome, Italy, okay? The menu has to be in Italian. It only makes sense. It's the native local tongue. So this is our menu. But Rome is a very international city. You're going to have people from all over the world that are going to want to eat at your restaurant. And all of them are going to speak different languages. Okay, maybe not all of them, but we'll say people who are coming from other countries are not going to be able to read it in Italian. So we have to get it into their language somewhere. There's no way around that. Someone who comes and only knows English is going to need everything on here in English somehow. And there's two ways that we can think about that. We could send this away to a translator, right? Send it away beforehand, give them all the time that they need to put it together, and they'll come up with an English version, and they'll come up with a Hindi version, and they'll come up with a Mandarin version, right? Whatever languages we might need, so that when the customer shows up, and this will be later on, we'll make a circle here for our English speaker. We'll grab the English menu. The Hindi speaker will grab the Hindi menu, right? The Mandarin person, and so on. This is awesome because this has already been done, completely two-step process to get it into the customer's hands. They'll never even know it was in Italian because there's no time that passes from when they grab the menu to when they can start reading it. Okay, that's one way. Another way is we could hire some waiters that are multilingual. So we've got, and I'll put our waiters in triangles here. We've got one that speaks English and Italian. We've got another one that speaks Hindi and Italian. We have another one that speaks German and Italian, and so on. Exact same process over here. Our customers come into the store, but instead of grabbing a menu off of the rack or whatever in their own language, they will be assigned, the English speaker, the English Italian speaking waiter. And this person will walk them through what's on the menu. Here, you can point at stuff in the pictures if you want, or I can translate everything one at a time. The advantages here, they hopefully are already obvious, but you can think about it up front here. If we make any change to our menu here, that's a big problem here. We're going to have to send it back to the translator, or the customers are going to have out of date menus. On the other hand, like I said, the huge advantage here is this is so much faster because there's no need for this intermediary step. Over here, right, we have to spend maybe more money to get waiters, right? It's going to be a little bit more confusing because he might have a bad day and maybe they don't communicate quite perfectly, or the menu has changed slightly and it catches them off guard and it takes a second to catch up or whatever, right? There's lots of positives about having it this way. We have a menu change, no big deal. We don't have to reprint menus. We have interaction directly between customers and waiters, but it takes more time, etc. Okay? Again, I love this illustration, and I've conveniently drawn the corresponding element underneath, right, interpreter and compiled. But let me put up here a couple terms. The Italian menu here is our source code. And our source code has the word for in it for our for loops. It has the word if in it for our if statements. It has a bunch of variable names, right? Those things mean nothing to a computer, right? You may have heard me talk about this before in other videos. The computer doesn't even really understand a 1 or a 0. It knows on or off. We refer to on as 1 and off as a 0, but a computer just knows on and offs, which is, we'll just call it binary. The customer, right, being our end user, which is the application, it is the machine running our code. It has to be in machine code. That is not optional. It has to be 1s and 0s it has to be in binary. Okay, I'll just put binary over here. Exact same thing though, machine code, 1 zeros, etc. Right? This is not optional. Just like it's not optional for our customers. They can't read it in Italian. They're not going to order anything if they can't understand it. The machines have to have it in ones and zeros. The issue is not if we compile it, or rather if we convert it, but when. Okay? In this case, for our compiler, our translator is a completely separate step. So we have a very much a step here, and we have a separate step here. Before it ever gets to the machine, it has gone through and been converted. So it gets there in its finished product. Over here, what we have, we punt that process, we punt the machine code conversion process to when the application is run at runtime, meaning the waiter is going to do it, right? Our interpreter is going to translate the code into binary when the application is run. Alrighty? Now, let's talk, before we talk about advantages, disadvantages, what's better, right? What should you be using? Just talk about some of those caveats. Strictly speaking, no language is actually compiled or interpreted. The language itself is just syntax and semantics. Okay? Getting it into that machine code, that is the compile process. C is just for and if and so on, right? Getting C into machine code, well, that C typically uses a compiler, but you could use CInt, and you can do some research on that. That's an interpreter for C if you wanted to use it. I don't know of any way to go directly from JavaScript to native machine code. There might be, but I'm not familiar with it. You can, though, run through a transpiler, like take JSXX, run your JavaScript through that. It will convert it into C++, which then can go directly to machine code. And in that sense, you could kind of move JavaScript to the other side, right? So the languages themselves can move around. It just depends on how you get them to machine code. Typically, C and C++ programs are always going to be compiled except in those niche cases. Also, this is not an in-depth class on compilers. If you've got advanced knowledge of it, I'm happy to say there are college courses, there are multiple classes required to teach how compilers work and potentially how interpreters work. So this is not simple, and I am making it simple so that we can have some understanding and maybe bridge going down the road. There are also, right, we'll get to this again, Java and C#, they do a little bit of a hybrid called just-in-time as well as ahead of time, and we'll come back to that. Let me clear this off quick. Okay, so on to the big question. Which one is better? Which one should you be using? Which one should you be leaving behind saying that's not any good? If you're already in this camp, you might be looking at disdain with those, thinking they're not real programming languages. And if you're over there, you might be looking at those thinking those are scary, difficult languages that are way too inflexible and I don't want to use. Okay? In my experience, neither one of those is true. And the truth of the matter is the answer to that question, which one is better, it absolutely depends on your application, on your business circumstances, on your competencies, on how much time you have, etc. There are benefits and drawbacks to using both, and so it's much easier to talk about them in terms of their advantages and disadvantages, and then look at it that way at the end. So we'll start off here. The first advantage I'm going to put for compiled is that it's fast, and the first one for interpreted is that it is fast. I will explain. The first drawback, so advantage in pink, drawback here in blue is that it's slow, and over here, you guessed it, it's slow. Okay, what do I mean? Well, and I'm going to try and juxtapose these, right? An advantage and then the corresponding disadvantage, and then try and do the same thing over here so that we can kind of have some nice synergy. This is going to be fast at runtime. Okay, going back to our illustration. This is going to be, right, the customer can grab the menu and immediately start reading it. That compile step, that has already happened well beforehand. We don't have to wait for it. Over here, it's going to be slow, or I should say slower at runtime, because that step hasn't happened yet. We have to do it before the code can run. The application is ready to run. We have to interpret it, right? Whether it's Python, whether it's PHP, if it's JavaScript, it's Ruby. Ruby's not up there, but anyway, you get the idea. In contrast, over here, this is going to be slow in development, or I should say slower. If you work in one of these languages, you get used to this, but every time you make a change, you have to compile your code again, and that takes time. Just like every time you make a change to the menu, we have to send it back and get it translated again. Over here, it's going to be fast in development. And this is hard to overstate it. It might be easy to think, oh, I want the end result to be fast. It's so much faster in general, right, to code in these languages. And there's lots of reasons for that. But you make a change, you can immediately go and refresh the browser, or run Python again, or run Node again, or whatever, and you will see that change affected. So that brings us to our next one, which is going to be fewer errors. And over here, unfortunately, we're going to have more errors, or errors are going to be more common. Okay, on the positive side over here, it is easier to learn. And over here, it's going to be harder to learn, or maybe harder to code, or more strict. Lots of ways to say this. And of course, there's always exceptions. I'm more than happy to agree with that. Fewer errors because, right, again, in our illustration, we send the menu to the translating company. They have time. They're not under any pressure. They can go carefully through it. They can go back and forth between, you, the manager, what you want it to say and what they're going to put. The compiler can make all the right decisions and can say, hey, you made a mistake here. This isn't okay. Over here, if you've done JavaScript in the browser, you've definitely had the browser break, and that's because, right, the compiler might have caught that if it was a compiled language, but instead it happens at runtime, which again, more errors. It's easier to learn though because we don't have to go through that compilation step every time. We can have some dynamic typing. You don't have to manage memory. You don't have to do pointer arithmetic, any of that stuff. Over here, you do, right? And maybe that feeds into it's faster or slower to develop, but there's a lot more to manage over here, which results in fewer errors, right? It's stricter because these are heavily typed, whereas over here, they're not. For our next one, you have no interpreter, and this kind of goes back to that first one. And over here, it can run anywhere. Anywhere you have the interpreter. The downside here is it is machine or architecture specific. And then over here, you must have the interpreter. Okay? There's no interpreter, again, meaning grab the menu and start reading it, right? The machine code hits the machine. It's going to be an exe file or a DMG file. It can immediately start running, but it's going to be very specific. You can't run a DMG file on a Windows machine. You might be able to convert it somehow, but that's not how it works. It's architecture specific. Over here, you can run anywhere, right? If it's JavaScript and it's going to run in a browser, you can run it on a PlayStation 5 if it has a browser, right? As long as there's an interpreter, wherever Python happens to be at, on a Linux machine, on a Windows machine, on anything, it can run anywhere, but that means you have to have that interpreter in there. For our JavaScript, that's the JavaScript engine. It's Chakra or SpiderMonkey or V8 or whatever, right? All of those, right? Trade-off, right? Got to have the interpreter, but that means the interpreter can go anywhere, just like the waiter can go anywhere. Over here, we don't have to have that interpreter, but you are stuck to that machine. Another big win here for this side is that the code can be optimized. And over here, we will have a unified, or we can have a unified code base. Okay, the alternative over here, it's going to be optimized, yes, but that means we are potentially going to have a divided code base. And these aren't quite juxtaposed to each other, but you get the idea. Divided code base. And this will be not, at least we'll put as optimized. The optimization process, the compiler can run it through because it knows what machine this is going to run on is significant. We can talk about this in other videos possibly, but the compiler is able to do constant folding and loop unrolling, things like that, where the loops that running in C, because it can be optimized by the compiler, are so insanely fast compared to a Python loop. Like 10,000, 50,000 times faster, literally, because not only is it already compiled and in machine code, didn't have to be interpreted, but it can actually be optimized, not just optimized, but even specifically for that particular machine. It does mean, though, you're going to have a divided code base because you're going to have a separate menu for every single language that you're going to put it in, right? You're going to have a DMG file for your Mac. You're going to have an exe file for Windows, etc. Over here, you get the joy of a unified code base. You only have to write Python, one Python code base, right? You only have to have one JavaScript code base. It's not going to be as optimized, right? But you only have to write it one time. Over here, you have to write specifically for that particular architecture. Back over here for our number 5, you get some awesome control. The downside, well, we'll come over here. You get flexibility. I'm going to contrast that here. 5, you have some responsibility. And then over here, you will lose some control. And let me define these. You have control in the sense that it is machine specific. You can be very, very clear about what happens, when it happens, where it happens, right? The memory is going to be managed probably by you, at least in the top line there. That comes with responsibility, though, because that can lead to blue screens, right? You're going to make potential mistakes as the developer because you're in charge of more. Memory leaks, things like that, right? Buffer overflows. Over here, you get the flexibility of being able to run it anywhere, which means you don't have to do any of the memory management. You're going to have less of that problem, but you have no idea what kind of machine it's going to run on, because the Python could be running on an Ubuntu machine. It could be running on an old Windows machine. It could be running JavaScript in a browser on an old phone or on a really powerful MacBook Pro. So you lose control here, but you gain quite a bit of flexibility and latitude internally. Over here, you get a lot more control, right? But you have to be significantly more responsible because you're in charge of so much more. Lastly, I'll throw up here, this is private. The code, when it is compiled, it's in machine code. Now, there are reverse compilers, so it's only kind of true. Over here, the win is that it's viewable, which means you can edit it. Over here, if you've got an exe file and there's something wrong with it, you are stuck with it. So the drawback is that, yeah, you cannot edit the file. But the drawback over here, of course, would be that it is public. If you want a Python file to run on a computer, you have to give the actual source code because it's still source code. It gets interpreted at runtime. That's great, though, because it's viewable, meaning it's editable if it needs to be changed. Over here, right, it can't be changed unless you have a reverse compiler, which is a totally different topic. You can always add more to both of these lists, right? But that's a good idea. It should give you a good idea of which one is better, right? It really comes down to which one should you be using. The application. Is this stuff more important, right? Are these higher priority than these? Or, right, can you live with these? Or can you not live with one of these, right? Is it not okay that it's slower in development, that you have to compile it every time? Is it not okay that it's architecture specific, right? You want a unified code base. Well, you need to go over here, right? Is it okay that you get some errors potentially at runtime? Or that it's not as optimized, right? Does it need to be as fast as possible? Do you want all the errors to be caught up front? Those are the kinds of questions you should be asking, like which one should you use, right? Which one is the right one for you? You have to decide the trade-offs, which one is better. And at the end of the day, it may simply come down to which one do you know. Is JavaScript what you know? Well, this is what you have. And it's okay, right? You can work with all of those things. It's just, right, a C loop is so much faster than a Python loop, but a Python program can run virtually anywhere, and a C program, it's only going to be stuck on its own architecture. You get the idea. Let's real quick wrap up with how Java and C# work, how those question marks are. Those operate on an idea called just-in-time. I'll go ahead and put that in here, as well as ahead of time. And there are other programming languages that do this. Again, the lines are getting blurrier all the time. But what happens is we start off with our source code in these languages. And we pass it through, I'll use Java as our example. We pass it through Java C. And Java-C uses ahead of time compile. Okay, and what it creates is not machine code, it creates bytecode. This is kind of an intermediary, right? This is like it's kind of in Italian and it's kind of in English, right? But it's not really either anymore. Why do you do that? Well, you go from bytecode. Okay, this is step one. So just like over here, we've got a completely separate step. We've done some compile, right? We've done some translation. We get over here to our end machine. So this is where the application is actually running. And in that process, it goes through just-in-time compiling, or the JVM. This goes from that sort of Italian English, right, the Spanglish or whatever, right, into the actual machine code. So this is trying to grab from the best of both sides. Let's do some of the work up front, but we'll have some latitude at the end. Java's tagline for a long time was write once and run anywhere. The joke was write once and test everywhere. But right, just kind of like the interpreter, you can have the JVM running on any machine, but it doesn't have to do as much work as an interpreter. But again, it's on any machine, unlike these compiled languages. Which one should you be using? Compiled, hybrid, interpreted. They all have their advantages. I have used all of these languages. It just depends on what you need. Just like human languages. Are you in Germany? Are you in Italy? Are you in China? Are you in India? Are you in the United States? You make the decision based on what you need and what you can live with, and you go from there. Thanks so much for watching. I will link another CS Thursday video, and I will see you next time.